Good morning, welcome. Everybody ready for the party tonight? Should be a lot of fun. So I'm actually from Orlando. My name's Joey. I live in Denver now, but I spent 13 years here. If you haven't been to Universal, definitely go. It's a blast. One of the coolest things, especially if you're a Harry Potter fan, but even if you're not, just the rides, everything is great. So today we're going to talk about quick starts for Terraform and Azure. If I can find my mouse. But before we do that, I want to introduce you to a little bit of where we are. And if you've been here for the last two sessions that I've done in the last 2 mornings, which I see a lot of familiar faces. Actually, who came to one of my sessions before, the last 2 days? All right, less people than I expected. That's good, because I don't want to bore you with the same thing in the morning. But you're in a Microsoft Technology Center. We're one of 16 facilities in the US and about 50 in the world. I happen to work for Denver. We're an organization that helps people envision what they can do, educate them on our products, and then execute on delivery. So that might be through high-level strategy briefings, architecture sessions. We've got a Service Hub in here. We have a Service Hub in here because we spend about probably 80% of our time on the whiteboard at the MTCs. So you come in, just walk through architecture diagrams, try and understand your business problems, try and figure out what you're trying to do, what technologies might apply to those, and how do you go build them. But then we also help out with POCs, hosting hackathons, all kinds of things like that. So if it's something you're interested, come see me after. We, like I said, have a presence all over the world. We focus on all kinds of things. My specific background is in application development. I'm a software engineer by trade. I help people build software now. But we have people that focus on modern workplace, data, infrastructure, our Power Platform, anything like that. So any kind of thing across the entire scope of the Microsoft ecosystem, you can come into the MTC and get help with. So great facility. Sorry, I'm used to having my Surface Pen, and the batteries died this morning. So yeah, as I said, we're all over the world. We often have rooms like this. You're in an Envisioning center. Every MTC in the world has a room very similar to be able to come in and experience the art of the possible. We do a lot of kind of modern workplace style demos in here. I'm usually in a little bit more smaller, intimate settings. We do run big workshops, but usually it's 5 to 7 people just sitting down, hammering through some specific problem. So a really, really effective tool that you can use. We don't like to say we're free, we're included. You're Microsoft customers, we're just a resource. So talk to your account team if you ever want to come in, have help with anything. I love to call that out because one of the biggest mistakes that I see customers make is just they don't ask. We have such an incredible amount of resources available. As you can see, if you just walk over onto this side of the room, all the people that are there, but there are thousands of people out there just dedicated to support customers full time. So please ask for help anytime. So my name's Joey. Like I said, I'm an app development architect. I spent a number of years here in Orlando building out an IoT platform in Azure, managing a couple million users, a couple million devices, all built with platform as a service offerings, kind of taking a newer mindset to application development, kind of riding the bleeding edge of what is the cloud. And now I help customers with that from day to day. And that's put me in a position where I've always tried to pay attention to the new trends, see where customers are going. And now in my role, I get to work with hundreds and hundreds of different people. Every day I have different customers coming in, different companies coming in with different problems, different issues, different personalities, all kinds of different things. And that's led to really seeing some common trends. Something that everyone is talking about, and everybody has been talking about for a while, is of course DevOps. And I always like to start this out. Almost all of my conversations start about what is it? And even though we're here to talk about tools or products, something very specific, DevOps is really, it's the union of people, process, and products. And I always love to highlight that because the products are like that top 10%. The products are what help you go really, really fast, but they're helping automate what your process is. And if you don't have a good idea of what your dev process is, then you're just going to run into conflict really, really fast. And that process is built on top of people, and people run on trust and open communication. And having a general mindset around, we're talking about the tools, but these tools are helping us deal with organizational changes and helping us go faster based on some underlying changes within our organization, within how we work, within how we interact with people is really, really important. So I always love to level set with that because just talking about the tools isn't always enough. The tools are really just a side effect of a broader conversation that we want to go together much, much further. And the word DevOps, if you think about it, it comes from dev and ops coming together. So for the longest time, we've got developers building and testing products. We've got ops sitting over here that are deploying them, provisioning, maintaining them, sending tickets back. We used to have this really, really big wall. And I heard someone once reference to that wall in between them as the chasm of despair, which I really liked. Because we were just kind of developers, I'm heads down and tinkering away at my keyboard, and I chuck code over the wall, and I just hope it makes it out there. I don't really care. That's gone. As we've started to move to the cloud, provisioning infrastructure, building new platform as a service offerings, it's so easy. Being able to stand up a website in Azure, hosting a .NET app with 500 nodes takes me 10 minutes. Even standing up something as robust as Kubernetes. I don't know if you've ever seen the article, Kubernetes the Hard Way. But it's basically taking you through the entire process of actually installing your etcd cluster, setting everything up that you would need. It takes hours to days. I can do it in like 5 minutes, one command. Just AC, AKS, create, and it rolls out. And so things have changed dramatically where I don't necessarily need somebody full-time setting up infrastructure and patching things for me, because so much of that is taken care of for me. And that's let us be able to take a lot of these different pieces of the product development lifecycle and put them together. And so we're starting to see devs have more of a focus on what our infrastructure is. And we're starting to see operations folks have more of a focus on developing. Even for the last 10 years, a lot of what ops is writing out scripts. Writing out scripts is really writing out code. It's just a little bit abstracted from where we are. And so we're starting to see a lot of tools come together to make this easier. And one of the big things that we'll talk about a lot today is Terraform. So as we're looking at dev and ops coming together, as we're looking at cross-functional teams that are working together, we're starting to see, can we get our definition of what our app looks like and our infrastructure looks like all in the same place? And that becomes critically important. But there's a lot of business reasons for why. So companies that have really embraced this go way, way, way faster. One of the things that I get to do at Microsoft is poke around in a lot of really cool repos. And so I have access to the Azure DevOps repo for Azure DevOps. And there's a pipeline in there I was looking at once that had deployed about 10,000 times. That's a lot. That's a ton for a product that's really only been around a few years. So there's lots of iterations, but that current life cycle of that pipeline, that's only been 3-4 years tops. So you can do the math at how often we're deploying, how often we're making changes. And that doesn't mean it makes it all the way out to the customer, but how often we have changes coming in, so we're rapidly iterating. Companies that really embrace DevOps deploy about 50 times faster. And they're not only deploying faster, but they're deploying with a lower failure rate. And it's not that we're writing better code. Maybe we are, but we're probably writing worse code because we're moving way, way faster than we ever have before, but we've put guidelines in place to make sure that it's safe. We have good practices to where, as a developer, I'm not going to deploy something that isn't going to run on my existing infrastructure, because now that's all part of the same team. Some of the other stats here, faster mean time to recovery. It's like almost 3,000% faster. If you have a good pipeline to deploy, if I break something, I don't roll back. You hear a lot, fail fast, fail early, fail forward. Just go fix it, because it takes almost no time to deploy, so fix the bug and roll it out. Don't roll back. Faster lead time to changes, too. In a Monday morning meeting, can I come up with an idea and have it out in production by Friday? That used to be impossible. It used to take 6-8 months. Now we see stuff like that happen all the time. So lots of reasons of why companies are starting to look into these best practices. And part of that, as we have dev and ops come together, we're starting to see a tool set come out to make that easier, to make those transitions easier, to make them be able to work better together as devs are having more of a scope of what their application actually runs on. Because an application used to be, maybe some load balance VMs running Windows with IIS, and that was it. And as an app developer, I just deployed to that, and it was always the same. We don't do that anymore. If you look at a modern cloud-native application, we've got platform as a service stuff, we've got microservices, maybe running in something like Kubernetes or Service Fabric, we've got serverless functions, database as a service, message queues, IoT hub, all kinds of different pieces together. I might have 40 different things in my application, and it's constantly changing. Something like Azure Functions, I might be deploying a new function every single sprint. If I have dev and ops as totally separate groups, does it make sense? Am I constantly getting people to go provision over there? And so we're looking at a set of tools that can help us embrace that. And infrastructure as code has become really a best practice that a lot of people have seen, not just for being able to have a better idea of what their infrastructure is, but being able to move a lot faster. And so can we define provision and configure? So define, can I write in a declarative manner what my infrastructure looks like? So not a set of scripts to go deploy it, but what I want the ideal state to be. So I can have something that's idempotent. So I can have something that I can run multiple times and say, does my infrastructure match what I want it to be? And if not, can you go make it? And so we'll talk about Terraform in a minute, but Terraform is a tool to help do that. So there's really nice syntax, really nice language to define everything in Azure, and then a tool to say, go deploy that. And then on top of that, can I take my infrastructure, can I take my environment, and can I go configure it? So can I do a little bit more than just standing up resources? Because once I stand up some VMs, once I stand up some app services, that doesn't mean that I have everything I need to dump my application on top of it. And so can I build that into a set of tools as well to make sure my environment is always how I want it to be? And actually, the word infrastructure as code has gotten weird for me. I really like to think of it as environment as code, because what is infrastructure? I mean, it is what your app's running on, but when you go over to the infrastructure as a service booth, you're just going to hear about compute, storage, and networking. And infrastructure's really gotten beyond that. Brendan Burns, who wrote Kubernetes and is one of our distinguished engineers, was talking about a product we have, Azure Container Instances, which is basically just start up a container, and he called it serverless infrastructure. And that really was weird to me, because that's exactly what it is, but people think infrastructure is something different. So there's a lot of different infrastructure as code tools that are out there, but why do we want to use them? So as I mentioned, standing up environments as fast as possible, getting the most efficient way to get something stood up. So I'm going to show you a demo later of a tool called Service Fabric. Has anyone here used Service Fabric? I'm just curious. A few of you. It takes a long time to get a cluster stood up. It's a pain. And I mentioned that because I used to run a Service Fabric cluster at my last company 4 or 5 years ago. There's so much stuff to provision. It would take about a week to get the cluster actually up and running and doing what we want. Every time we would onboard somebody new, we would onboard a new partner, they wanted their own infrastructure. It'd take us 2 to 3 weeks to actually get the environment up and running, have things deployed, have things tested. Eventually, I realized that was untenable. We were onboarding partners really fast, moved to some infrastructure as code tools, and got that to stand up in about 30 minutes. So just the overall time to be able to deploy became so much faster for us. And with that, that means I have a whole new disaster recovery plan too. Depending on the company, I mean, if you want multiple hot zones and high availability and being able to route traffic, that's great. But for a small startup that doesn't have enough money to spend an extra $10,000 a month on a separate deployment, my DR strategy might be, I can stand everything up in 30 minutes. Maybe that's good enough, as long as I have my data. And then removing the human element. So people make mistakes all the time. I certainly have. Who here's fat-fingered something and broken something in production? Probably more people than have raised their hands. If we can remove the human element and repeatedly deploy the same thing every single time, we're going to have a much higher quality to what we're doing. And not just being able to remove the human element, but we're putting our infrastructure in a place where other people can see it. And so when I'm going into the Azure portal and I'm provisioning resources by hand, I'm probably the only person looking at it, unless you're pair programming setting up Azure, which is probably not happening. But now I can actually have multiple people look at this file before I go run it, to get some pretty high confidence that it's going to do what I want it to do. So improving visibility is a really big thing, and then improving efficiency. So going through the Azure portal and creating stuff, it's a great experience, works perfectly fine. But if I need to create 3 app services, I'm probably going to do the same set of steps the same time, and it's going to take me 10 minutes each time. I can write one template, copy, paste, copy, paste, copy, paste, deploy, and have everything up in a few minutes. I've actually gotten so efficient with Terraform specifically that I usually just write Terraform. I don't even go into the Azure portal for a lot of stuff, because it's just so much easier for me to grab my pre-provisioned templates. And that's some of what we'll talk about today. And then I can also store my infrastructure definitions alongside my code. So for the longest time, our apps lived over here, and our infrastructure lived over here. And if you were to ask the apps people, what do you need for your application to run? Or if you need to ask the ops people, what do you need to run this application? A lot of times, nobody knows. This happens to me a lot when we talk about app migration. People come into the MTC, and they say, hey, I want to move to the cloud. I want to get all this stuff up here. I'm like, great. They're usually saying, can we containerize it? I'm like, absolutely. What do you need? What are the dependencies for this application? What's it supposed to run on? And a really high percentage of the time, people go, I have no idea. And that's really dangerous for your company, because we've babied servers for a long time. Over the years, I've just installed different things on them, patched different things on them. It becomes really hard to know where things are. Well, now I can take my infrastructure, I can take that configuration, and I can keep it right next to my code. So in my repo, I've got definitions for everything to run my app from the ground up. And that becomes really critically important, because we can do some really really neat stuff. We can take all the best practices for software development, like branching and pull requests, code reviews, and now apply them to our infrastructure. And so our ops folks can have the same level of rigor and quality that we've always had with software development. It's a little bit new, and when I mentioned DevOps is a lot about people, that's a concept that's hard for some people to swallow, because it's just different from what we've been doing for a long time, but it's a much, much, much better practice. So now my Git history has a full audit of my environment, which is really cool. So what is Terraform? So Terraform is a product put out by a company called HashiCorp. They actually have a booth here. They're in booth 2013. I will be there later today if, kind of after the session, we'll move over. And is Mark here? Mark's in the back waving his hand. He couldn't get in. Mark is with, with HashiCorp. He'll be around, too, to help answer questions on Terraform, Vault, or any of the other tools that they have. But Terraform is a tool for writing infrastructure as code. And I say infrastructure as code, but it's really even more than that. So you can write declarative configuration files. You can plan and predict your changes. Some of the things we were talking about a little bit earlier is one of the features of Terraform. I can say, go look at my environment and tell me, what are you going to do? One of the really big things that's beneficial about something that's declarative is that as a script, either I have a whole bunch of if statements to say, is this here? No, create it. With something that's declarative, it's going to look out, interrogate my environment, and say, I already have a resource group. I already have my 3 storage accounts. I already have a VM. Oh, I just need to go add this Azure function. And so it's just going to do that one thing. With Terraform, I run a command called plan. Plan reaches out and figures out, what am I going to do? One of the other things that it can do is be parameterized. So I can pass in variables to say, here's what my environment name is, or here's what my deployment name is, which means I can write one template and deploy that same template to dev staging and production with different configuration, maybe different VM sizes, different node counts, all kinds of things like that. But the practice of being able to build once and deploy multiple places that we've had for software for such a long time, let configuration live in the environment, we can now apply that to our infrastructure as we're doing our deployments. And then creating something that's really easily reproducible. So I can take my existing environment and stand it up somewhere else really, really easily. If we get into continuous integration and deployment, which I had a session on earlier in the week, which will be posted online, how to use Terraform and Azure pipelines, one of the things that I can do, I've got dev staging in production. What if I want a QA environment, and I only want a QA environment for an hour to test something? In about 30 seconds, I can copy-paste the release definition, change my variable name from production to QA, redeploy, and the whole thing rolls out. I even have a lot of customers that are saying, I'm doing load tests. Load tests are expensive because I want them on a real production environment. That might mean standing up like 40 nodes. Well, I don't want to stand up a load test environment permanently, and it's kind of a pain to schedule. What if every time I go to do a deployment, I created my entire infrastructure, ran all my load tests against it, got all the results back, and then blew the whole thing away? And so you can have your load test environment run for 5, 10 minutes, where something that might have cost you thousands of dollars a month to keep up costs you like 10 bucks. And so Terraform's a tool to really, really help with that. And it's completely free, open source. The whole thing's on GitHub. But of course, HashiCorp has to make a profit here. So there's a service as a part of it if you want to have an even better experience. So one of the things that you'll get when you're writing Terraform is a command line executable. I can go, and we'll show you a demo in a minute, write my Terraform templates, init, plan, and then apply my templates, see how they're going to look, have it provision my infrastructure. All those features completely free. You can build things into pipelines, use the extension for pipelines to deploy. But a lot of times people need more. So one of the things Terraform does is keep state. It knows what it's working on. It knows what resources it's supposed to manage within Azure. So it's not going to be in conflict with your people actually going in, because there's some things I might want to do by hand. Maybe if there's something in preview and it's not yet out in Terraform, I can go in and create some resources. So that state file becomes important, but that state file lives wherever I run Terraform. And so I need to put that somewhere. It could live on my local machine, but if I have 2 or 3 people running the same templates, they're going to be in conflict because we have different state. And we can keep them in a storage account. We can keep them in a bunch of different places, but one of the places you can put them is Terraform Cloud. So HashiCorp has a hosted service or self-hosted service if you want to set it up on your own and have that provision your infrastructure for you, where I can keep all of my state and then do a lot of collaboration on it. So I can get a nice visualizer for what have I deployed. I can have collaboration to be able to say, I'm editing my templates. I want you to be able to edit my templates as well. Can we set the back end somewhere else? to make sure that we can have a really good experience? Can I put in role-based access control? Can I write really detailed policies around saying, as you're doing a deployment through Terraform Cloud, and the way that it really works is when I run my Terraform CLI, even if I'm going through my typical command line process, if I have Terraform Cloud set up, it's actually going to reach out to Terraform Cloud and have it do the deployment for me. So it's actually going to deploy from their agents. And that lets me write some really, really robust policies. So I might set up a service principal to Azure that has full rights to a subscription, full rights to a resource group, but I might want to say, hey, John right here only has access to deploy virtual machines, or only has access to deploy app services, or only a certain number, or only certain times a day, all kinds of different policies that I would want. And so Terraform Cloud and Terraform Enterprise bring in a higher level of role-based access control, governance, automation, collaboration, make it a really nice experience, especially if you're coming from the ops world, if you're coming from the IT world. This is going to be a really, really great fit for being able to write my code and deploy my code and collaborate with other people without necessarily having it be part of my application pipeline. If you're coming from the dev space, you can also orchestrate all the deployments through Terraform Cloud right from Azure pipelines. And one of the new cool things is also saying cost. How much is this plan actually going to cost me? What's the change going to be? And so cost estimates are a relatively new feature that were announced in Terraform Cloud as well. So really great product. But let's get to the heart of it all. So Azure and Terraform. Azure and Terraform go really well together. I'd love to take a minute to talk about our partnership. So I'm not just talking about some random third-party product that you could go run. HashiCorp is their own company. I work for Microsoft. I use Terraform almost exclusively for infrastructure as code. I've noticed that becoming a trend across a large portion of the company, just because it's so easy to use. It was designed from the ground up to be written by people. Some of our other products may not. Who here's used ARM templates? You'll see what Terraform looks like and understand the 0 to getting something deployed is a lot less. And so we've seen a lot of adoption. But Terraform isn't just a provider for Azure. It's a provider for whatever. So you can write templates that you go deploy to Azure, but you can use the same tool set to deploy to AWS or GCP or even on-prem. So it interacts with vCenter, and it'll actually go scaffold out virtual machines for you in your own data center. And so I can have one common tooling set across a lot of different clouds. But beyond that, there's also providers for all kinds of other things within the cloud. So Kubernetes is a big thing. Going in and running kube control and making changes to my application and setting up ingress and all these different steps that I might do every single time I pave down a cluster are kind of complicated. I might not remember exactly what they all are. There's a lot of babying to do to get everything how I want. There's a Kubernetes provider for Terraform where Terraform can actually do that configuration for you. And then even the next step on top of that, if I'm using a package manager for Kubernetes like Helm, I can actually provide all those baseline scripts using the Helm provider. Or even if I want to go do an app deployment, anyone here using Let's Encrypt for their certs? A few of you. So free SSL certs, basically. But a really, really great tool to be able to go generate SSL certs. There's actually an Acme provider, which is an automated certificate management provider for Terraform. And I can actually have Terraform reach out and say, hey, provision me an SSL script or an SSL cert for my application. And I can chain all these together to say, as part of my deployment, I've got my app service, but my app service needs SSL cert. So I'm going to grab the SSL cert. I'm going to put it in Key Vault. I'm going to put a Key Vault reference to app service. And so when my app service stands up, it's provisioned correctly and has all the certs that it needs to go forward. And so I can do the same thing with AKS to Kubernetes to Helm. And I'll show you some examples of these really, really robust workflows that we're starting to get into. So Azure and Terraform, as I said, they go well together. But it's a little bit more than that. We actually have a contractual relationship between the companies. So there's a full-time product manager on the Microsoft side who's responsible for that relationship, for driving Terraform support in Azure. And I say that because I want to give you confidence in being able to use Terraform. It's not a first-party product from Microsoft, but it is a first-party supported product. So though there are tons of people inside actually contributing, we do have people full-time dedicated to helping support Terraform. And we actually pay HashiCorp to maintain the providers for us. So though they are all on GitHub, anybody can go contribute. I've contributed, hundreds of other people have contributed. The whole thing's written in Go. It's all open source. You can go compile it yourself if you want. It's actually well supported by us. So you might not see things that are immediately released in preview, because the way that Terraform works is it's actually calling our Azure Resource Manager APIs. So it takes a little bit to get the SDKs updated, but usually within a couple weeks of a service coming out, or usually right by the time it's generally available, it's provided within Azure, or it's provided within Terraform, no problem. I've run into very, very few resources where there's ever some kind of hiccup, and if there is any kind of hiccup, the one thing that Terraform can actually do is that it understands ARM templates as well. And so our native first-party templating, if for some reason you've got 90% of your infrastructure in Terraform and you say, hey, I got this 1% that is, hasn't been updated yet, or in something like some of the stuff that we announced in the last week, it's going to be available in ARM first. I can grab that template and put it in until I have a chance to switch it over. But if you've been using any other infrastructure as code tool, I say give Terraform 5 minutes, and you'll never go back. It's amazing. However, one of the things has become, it's really easy to write. It's really easy. If you go in the Terraform docs, there's excellent examples for everything across the board, anything that you would want to stand up. But it's any one resource. So if I want to stand up AKS, it's going to tell me everything I need to stand up AKS, which is an AKS cluster and a resource group. That's not a realistic workload. Some of this stuff like Service Fabric, a Service Fabric cluster, I'm going to get the definition for how to do it, but I actually need like 30 resources to stand up a Service Fabric cluster, because it needs VMs. I might need some way to do ingress, which is probably going to be API management. Or some other stuff like networking. I can see how to set up a virtual network. I can see how to set up a peering. But what about a pretty traditional hub and spoke topology with network security group rules and routing and everything already applied? Those kind of workloads become a lot to manage. It's a lot to figure out. Especially if you're new to Azure, we want to make 0 to running absolutely as easy as possible. So today I want to announce that we're formally supporting QuickStart Templates. So for the longest time, we've had QuickStart Templates in Azure. There's about 900 of them for ARM specifically. We're up to about 20 or 30 right now for Terraform. But I'll post the link in here. But later today, they'll go live, where you can see a lot of these complex business workflows already built out. So one of the things I'll show you is Azure Kubernetes service, but AKS running in a private VNet. So in a private VNet, I need to be able to get into it, which means I probably need something like an application gateway. And on that app gateway, I need a web application firewall. And to set all that up, that means I need private networking for AKS. And AKS needs to talk to Azure Container Registry. How do I pave down this entire environment in one command? And so that's what we've been working to put together. So Terraform Quick Starts for Azure. Everything's on GitHub. Everything's open source. And our goal is to say, can we bring you the fastest time to market for things that are more complex, things that are more complicated to do inside of Terraform? And it's not that the Terraform is complex. It's that all of these workloads working together is complex. And so can we provide a baseline for what we'll see? So defining common use cases. And this is something, this is new. Like I said, there's about 20 templates. Those templates are based on things that I see people run into often. They're the things that I write the most. This came from my personal collection of Terraform templates that I use with customers every single day. So like I said, talking about AKS, talking about app services to ACR, all kinds of things like that. But we want to expand that to be whatever you want it to be, to whatever you need. And so I have commitment from a number of people within Microsoft to help contribute. But we want it very much to be a community-driven project. If you look at the ARM QuickStart repo, we didn't get to 900 templates just by one person going in and adding 900 templates. It's very much community-driven based on what people want. And so one of the things that I want to come out of this, and I'd love to hear from you after I show you some of the demos and walk through what some of the different templates look like, is what's missing. What workloads are you working on? What would make it easier for you to get into Azure? Because if it's a problem that you're running into, there's 30,000 people here. You're not the only one. Nobody here is in a total unique situation. And so trying to provide some support to say, what's the cleanest way to do this? And then can we share it with the rest of the community? And then I also say, it's on GitHub. That's how we develop now. All of our new products and services, if you look, almost everything that we're building is getting donated back to the community, being available for anybody to use, for other people to build on. And so if you've created something that's really great, contribute it back. So some examples, and I'm going to walk through some details. Things that I've run into. So I mentioned that more enterprise-style deployment of Kubernetes. But something that's really simple even, static websites. There's some hiccups with getting static websites going. I want to host a static website on storage. I drop the files on storage. In the portal, it's a checkbox, but if I want to script it out, there's like 4 or 5 other things that I have to do. And this is something that's come up a lot, so this was just the first template I dropped in there. But what about web apps? Web apps for containers. I've got containers. Well, I need a container registry. I spelled ACR wrong. Oof. 3-letter word and it's spelled wrong. But my web application needs to talk to my container registry. I can stand up a web app really easily. I can stand up a container really easily. But how do I do role assignments within Azure within Terraform? And so that I can provide a managed identity for my web application and then grant that identity read writes to my container registry. And so I don't have to have any keys. I don't have to use Docker usernames and passwords, but I can let my web app pull my containers down. We're using managed service identity to talk to SQL. So who here is using SQL Azure? Is anybody talking to it without passwords? One guy. All right. So that's where you should get to. So within Azure, a really, really great feature that we have is managed identities. Managed identities means as my application is deployed and running in an environment, I can actually reach out to Azure Active Directory and say, I'm running in this environment, give me an access token to something. And that access token is scoped to who I am, who my application is. My application actually gets an identity inside the Azure portal, inside Azure Active Directory that I can go assign to things. And so I can say, my web app has access to my SQL database. And it has access based on this set of roles. And there's no keys. There's no passwords. It reaches out to it directly. And so if you're using the Managed Identity SDK, it actually reaches out to a non-routable IP that's running on that actual machine that can't be gotten from anything else, gets an Azure Active Directory access token that it uses to present to SQL Server to let SQL Server know that it's good to go. And so I can remove keys entirely from my application. Well, how do I configure that with something like Terraform? How do I set up managed service identities? How do I set up SQL? How do I enable the admin user for it? How do I then go provision, because there's a SQL provider for Terraform. How do I go in and then make sure to add that managed identity to roles within SQL Server? And then make sure that configuration's all the way back. So lots of different complex workloads, setting up Helm, hub and spoke networking. Probably the most complex Terraform template I've ever written is Service Fabric. So as far as I know, no one else has ever gotten Service Fabric running through Terraform in a single one-line deployment and stand up the entire cluster. But it does work. But getting into Service Fabric is kind of it's a little cumbersome. Setting up ingress, all those things. So a lot of people front it with API management, because API management understands Service Fabric and will route traffic for you. So how can I set up Service Fabric with API management as a front end and have those APIs automatically routed back to my services? So in one command, I can pave down my entire cluster, my front end, all my logging, all my monitoring, everything that I would need. Same thing with Kubernetes, and then CI/CD. So what does a best practice look like for taking this and putting it as part of my pipeline? And so we're starting to add some examples of those things as well. So I want to show you what this looks like. So I'm showing you this on my repo. Submitted the pull request this morning. Mark's going to merge it later today. It'll be on, I'll send you the link, but github.com/Azure/Terraform. And this is just an example of the templates that we have out there today. Like I said, this is based on my personal collection of things that I have worked on for the last couple years. But beginner, intermediate, more advanced kind of things, some stuff that's coming soon. But I'd love to walk through what some of these actually look like and what some of these actually do. So a really great one to start with, as I mentioned, who here is using containers or something? So we're starting to see so much traction getting into Docker and containerizing my application. It's a great migration story, whether you're on Windows or Linux. Windows containers, being able to take a legacy application. Sorry, I'm moving my glasses. It's moving my mic. Being able to take a legacy application and package it up without changing any of the code, and then go run it on something like a platform as a service offering. So can I take my .NET 3.5 app running on IIS, wrap it in a Windows container, and then run that on app services? That's a really awesome migration story to mean I don't have to manage underlying operating system anymore. I don't have to worry about patching things in Windows. I just worry about my application running. But when I do that deployment, I need to put it in a container registry, and my app service needs access to the container registry. So walking through, can I deploy my app service, and then can I actually set up those role assignments to ACR? So that's one of the things that we have on here. Whole bunch of other things, just getting some of the things that seem like they would be easy, but What does configuration look like for some basic apps? What does configuration look like for using Kubernetes but enabling the dashboard account? So if anyone here using AKS? Few people. So getting into AKS, configuring roles is kind of new. RBAC for Kubernetes has only been around for the last, I don't know, maybe year. It's something that Microsoft added and contributed back to the community. Once that's up, my dashboard's broken. It has no rights to do anything. So how do I enable that? Questions that come up. How do I get log analytics working? How do I enable Helm to make my experience as a developer really, really easy? So I want to dive into what a couple of these actually look like. So let's pick an interesting one here. AKS with Helm. So Helm is a package management tool for Kubernetes. Certainly go talk to the AKS folks about it. They're in the AKS and containers booth over that way. But it's a tool to make getting my entire application, all my configuration, everything that I would need up into a container management system. So one container might be my application, but today everybody's talking microservices. Everybody's talking doing distributed applications. We might be using Keta and running Azure functions on top of Kubernetes, all these different things that are happening. That's not just one single container. We're talking dozens of containers to deploy the application. So one of the things that Helm does is saying, how can I package all that up so in one deployment I can roll out a well-versioned set of my entire application together? And there's really great tooling to be able to take my application, all these different applications, package them up as part of a pipeline to where I just do Helm install, whatever my application name is. And so some examples, there's a lot of people use WordPress for stuff. Maybe I have an old website. I want to get off of that. I can do Helm install WordPress, and it's going to grab me a MySQL database and stand up a container for it, and it's going to grab me a container for my app, and it's going to make sure all the rules are there, and it's going to make sure ingress is set up and firewalls are set up, and everything that I would need to just go drop that in a running cluster. And I can write those for my application. So the general format of these, everything has a README with descriptions. Let me flip over to GitHub real quick to show you. Defining what resource type. So what is this actually going to go deploy to me, and what do these resources mean? This one only has 3 or 4. If I look at the AKS or Service Fabric one, there's like 30. What are all the variables? So what are the options? So I mentioned that Terraform can be parameterized. I can pass in variables. Some of the things you'll notice a lot, environment, DNS prefix, name. DNS prefix becomes incredibly important, so I'm really, really particular about naming conventions. Well, naming conventions with Terraform get easier because I can write my templates so the templates automatically fit my naming convention. So anybody using them, whatever they cram in, it's going to be named how I want it to be named. But some resources within Azure have DNS-based names, so they're globally unique. An app service, you can't deploy 2 app services with the same name. And so I'll make sure to put in a prefix. Location, where are they going to be? Plan tier, plan SKU. This happens to be an app service, so it's going to say what kind of app service is it? Is it a P1? Is it a P2? I could easily add parameters to say, do I want this on Windows or Linux? And then examples of what this actually looks like running. And we'll run one in a second. But what does the Terraform plan look like? What is the full set of details of everything this is going to roll out in my infrastructure? And so from here, one of the things that's really great about Terraform, compared to maybe some of its other competitors, is Terraform supports multiple files. You'd think that that would be common, but it's not, unfortunately. When you run Terraform, it's going to look at every .tf file in that directory. It's going to put them all together, and it's going to run things for you. So every template in here is set up kind of the same. Main.tf is going to have the providers that you need to find. So in this case, this is talking to Azure Resource Manager and Azure Active Directory. These are actually binaries that are written by HashiCorp that do the interface with the Azure Resource Manager API. There's only 2 here. If you look at some of the other ones, they'll have the Kubernetes provider. They'll have all kinds of other stuff like this. I actually think the Kubernetes one's defined in the Kubernetes file. A reference to a subscription. So I can actually, in the context, as I'm standing up resources, pull different information down. So Terraform has resource references. They also have data references. So as I'm writing out my templates, if I'm using something like AKS, and I've got 20 different app teams that are all deploying to the same cluster, they're not all going to have the resource definition for my Kubernetes cluster, because they're not all going to be responsible for standing it up. That's expected to be there, but I can give them a data reference to it. And so I can say data Azure RM AKS cluster. And that'll let me pull in things like the cluster certificate to be able to go do deployments or things like that. So in this case, I'm defining a resource group. This is what Terraform looks like. The one thing for me is that it's very easy to read. So Terraform is written in a language called HCL, HashiCorp configuration language. HCL is JSON-like. So you get some braces, but it also has some of the simplicity that YAML brings, where I don't need quotes around everything. So generally, things are broken up with braces and then just key equals value. No semicolons, no extra things that you need. But it also has interpolation built in, so I can make references between things. So in this case, I'm referencing the name of my resource group is going to be my variable name that I'm passing in for my resource group, the environment name, and RG. So in this case, this will be demo TF QuickStart staging RG. If I were to deploy it in production, demo QuickStart production RG. So it makes it really easy to deploy these to multiple environments without any changes. I can define variables in the variable file, set defaults, anything that I would want. It becomes really easy to write, but this is where it really starts to get interesting. So coming in here to say AKS. How do I actually deploy my Kubernetes cluster within Azure? So Azure RM Kubernetes cluster, this is going to define everything that I need to create my AKS application. And then can I define what are the nodes going to look like? So in this case, Kubernetes has agent pools. I have one defined right here for Linux. I can have some that have multiple. One of the great migration stories, I was talking about Windows containers. As I'm building out my modern application in something like Kubernetes, I've got all my new stuff there. What about all my old stuff? At Build this year, we announced Windows support for AKS. And so I can actually stand up a separate node pool of Windows machines, so Windows Server 2019 machines, so I can take Windows containers and actually manage them in the same way. I actually have a customer that has Windows containers running a .NET 3.5 app on IIS, serving something in Silverlight on AKS. And that just is an amazing collaboration and just taking this old technology but organizing it in a modern platform. So I have one control plane to manage everything. One of the other things Kubernetes needs to do is be able to change networks. So within Azure, I'm dropping pods. If I want the advanced networking, I want to drop them on a network in Azure. I need to be able to add resources to it. And so Kubernetes, the application itself, the cluster itself, has rights within Azure. Some of the other things I mentioned is saying, how does it get to the Azure Container Registry? Well, it gets to the Azure Container Registry through either a hard-coded username and password that you put in, or through using managed identities. And so I can actually say, I need an application identity for this. And so there's actually an Azure AD provider that I've referenced in here too to say the service principal is here. I want to enable role-based access control. So in this case, we're setting up Helm. So this is when I want to jump out of what's Azure and go into what's more generic. So I'm actually using the Kubernetes provider for Terraform. So any Kubernetes cluster that's existing, whether it's AKS, EKS, GKE, something that I'm running on-prem, I can use this provider to talk to those things and stamp down the same sets of configuration. In this case, I happen to be grabbing the certificates to talk from the Azure AKS provider. And then I'm standing up resources. So in this case, I want to create a service account for Tiller. So the package manager Helm uses a service account that deploys on behalf of. That's typically called Tiller. You can call it whatever you want. Everything Kubernetes is nautical themed, so there's lots of boat stuff. And so Helm uses Tiller, so this is creating a service account for Tiller. I'm creating a binding between the Tiller account and a role within Kubernetes. So it's going to reference the administrative role. I'm going to give it the subject, so it's going to say it's a service account. This is going to grant rights to be able to deploy to my cluster. And so this is going to have everything ready for me to set up Helm. And then Terraform actually has a Helm provider. So if I have a Kubernetes cluster that's up and ready to go, and using Helm, I can say, what do I need to talk to my cluster? What service account am I going to use? Go put something on it. And so in this case, I'm using Ghost. Ghost is just some blogging software. It just makes for a nice demo. One of the really common things, though, is to say, how do I set up ingress? So I need some kind of proxy service within Kubernetes running. Might be Trafic, might be Nginx. I could set this up as a package that's already pre-configured to get that all up and running. If I were to change this Helm release to be Nginx ingress, it's going to go grab me the ingress package and have everything pre-configured and ready on my cluster. So when I run Terraform apply, I go from 0 to something that I can start using in a few minutes, instead of 0 to something that I have to go do a bunch of configuration on. And so it removes all of the manual steps from it. And so I want to jump back over here and show you an example. So in this case, let me make this a little bit bigger. This is going to take a minute to run. But I mentioned Service Fabric. Service Fabric is massive. It runs tens of millions of cores within Azure, but it's a really, really cumbersome service to set up. So within the Azure portal, it can be pretty easy, but there's still a lot of things that you need to know. So I'm going to run Terraform plan. What do I actually need to do to set up a Service Fabric cluster? While this is running, I want to jump over to the template real quick and show you what it's going to try and do, or what it will do. And say within here, these are all the different types of resources. So Service Fabric itself runs on IaaS. So it's a container orchestration platform or an application orchestration platform, but runs on infrastructure as a service. All of this stands up on top of VMs, so I need a VM scale set, or sometimes multiple VM scale sets. Those VM scale sets need storage. They need to live in a network. How do I get into it? If I want to do Service Fabric with API management, how do I set up the back end? How do I configure API management? How do I do all of these different things? For me, as a customer coming in and approaching this, writing out these templates, this is going to take you probably days to weeks to figure out everything that you would need to get everything up and running. So even though the language within Terraform is really easy, it can be difficult to go from 0 to 100. And so what we've done is scaffold out as many of these as we can. So this is still refreshing my state. Like I said, this takes about 2-3 minutes to get through. But it's going to go out, it's going to configure my environment, or interrogate my environment and figure out what I need to do. So in this case, 27 different things to add. So if I scroll through all this, this is everything that it's going to go create within Azure. This is something that, if I were to do by hand, is really difficult, especially if you look at doing multiple clusters. Some stuff like Intune. Intune is in 18 different clusters around the US. They're all running on Service Fabric in the back end. Standing up 18 different clusters and making changes to 18 different clusters, if you can't manage this through some kind of tool, is just going to be impossible. So, to flip back, aka.ms/Terraform QuickStarts. This will link you to where the GitHub repo is. Like I said, there's a pending pull request for everything in there. It'll be in probably within the next hour. I'm going to go bug mark right now since we've talked about it to merge it in. But you'll be able to find these. But please go in and submit issues. Tell me what you want to see. What are your common workloads? What's missing? What works for you? What doesn't work for you? And contribute. Like I said, I want this to be community-driven. If you're big into Terraform, if you're writing stuff, start here and see how we can make it better so that we can all go faster together. So thank you for coming in. Have a great party tonight, and have a great rest of Ignite.